Okay, so actually the first one is, let me just share my whole screen here. Okay, the first is that one of the things that in doing a number of different classes, so we began with this one called MyFrame, and then in order to have a graceful closing, we had this window closer thing. Where was it? Down here. Okay, we had a window closer that was a window adapter, a window listener, and an action listener. And then when we were looking at another one, then we also pretty much had the same deal. Or was it? Again, we just sort of had yet another one. So when you start to see duplicated code like this, kind of doing the same thing, then what is useful is to recognize that that's sort of something that is going to be repeated. And so what you want to do is you want to basically put it in one place and just use that one thing. Because as I've said before, the optimal number of times to have any particular logic is one. And here we were in a situation where we had to keep kind of duplicating code like that. So what is the solution? Well, there are two possibilities. One is we could actually move this out to its own class, and then whenever we needed it, simply instantiate it. And that's something that's quite possible. The biggest challenge to that actually is right here where we have this confirm dialog, and that is we need to give it a parent. We actually don't have to, but if we don't, then that can actually create problems where the dialogue that we need to dismiss gets hidden behind something else if we don't give it a parent. Here, the parent is actually the, we kind of hard coded this into its enclosing class. So there's a way around that. Namely, we can, if we look at this window event, we can kind of see there's a setter method called source, and that's the object on which the event initially occurred. And we can get that source from this method, and then locate what the parent is, and that's a possibility. But instead, kind of a more straightforward one is to create our own base class, and I'm calling it base frame. And again, this is one of the things that I pushed. And the idea here is that some of the things that we were doing repeatedly are going to be in this base frame. We're extending JFrame, and so what we'll do now is we'll extend this class, this base frame. And all it does is it sort of sets a default size, because the default 0 was kind of flaky. It sets the default close operation to do nothing, and then it has the window closer in here that we've basically done. In addition, you notice that a lot of times we wanted a status, and you'll notice that in many applications we have, there's the bottom part of the window is often kind of giving us messages about what the state of things are, what's going on. And so to that end, again, in the base frame, I'm going to put a status label. Now, the thing is that when I subclass it, again, all the principles of encapsulation that we've talked about so far are still in effect. So since this is private, a subclass is not going to be able to directly access it. And I might want to sort of change what's going on with that. So to that end, we have a, oops, where is it? Yeah, sort of a setter and a getter. And unlike what we were doing with the containers, again, here I'm actually, like for the getter, I'm actually returning the label itself. And that's because if my subclass needs to update the label, I need access to the actual label, not a copy. And then the final thing is that we had this sort of init method in which we put all the different components. Here, the init method instantiates the window closer and adds the window listener. And one of the things that oh yeah, okay. So actually one of the things that I should do is make that an instance variable, because what oops, why are you, oops, window closer. Because I want to have a getter method for that, not a setter. Well, actually, I could have a setter. So let's put that in after init. And one of the reasons it wasn't there is because I wasn't really using it. But if we want to use the action listener, then we need to have access to that. So that's just something that is going to be in addition to this. Okay. The final thing is yeah, this init. Now, notice that before we were making it private, and the only issue with that is that if it's private, then subclasses can't call it. So what we want to do is you want to use this init method in our subclasses. And so in order to do that, I need to make it protected. You know, I could make it public, but protected is, again, protected is a little bit more restricted because I only want subclasses to have access to this. Okay, so that's the base frame. And what we're going to do today is look at how when we move the mouse around, then what is actually happening is mouse events are being fired. Whenever we do something with the mouse, if we just move it around, if we drag it around, if we click it, if we press it, if we release it, all of those will fire something called a mouse event. Now, up to now, we've been dealing with two other events. We dealt with, well, window events. When we were closing the window, there's this window event that gets fired whenever we're doing something to the window. We were also dealing with action events a lot. Whenever we manipulate a button or a menu or a text field, then it fires an action event. And if we're listening to that with an action listener, then this action performed method gets invoked. Now, in addition to that, whenever we do something with the mouse, then a mouse event gets fired. So there's this class called mouse listener, which extends base frame. We're not going to use any of the changes that I made. So if you don't have those changes to the base frame in there, it'll kind of work. So again, when we talked about how to subclass things, then all of that comes in. So we have a constructor. Since the base frame just had the zero argument constructor, that's the only one that we can call. And so we, you know, if I don't say super, then Java's going to put it in, but I want to put it in just to be clear that I'm not forgetting it. And as we have seen, there's a method called set, an instance variable called title that has a setter. And so if we set the title, then we can have pretty much the same kind of thing that we were doing before. So now here's the init method. And because it's protected in the superclass, because it's protected here, we can override it. Notice the override. Again, this annotation of override is optional, but it's helpful to understand that what we're doing is overriding something. So we call the super init. That makes sure that anything in the superclass gets executed in the superclass as init. And again, just to kind of kick things off, what we're going to show is the main panel here. I'm going to call it a mouse panel because it's going to be responding to the different mouse events. And what we're doing here is our J panels that we were dealing with had a layout manager. And we talked about the flow layout, the grid layout, and the one that's in the frame, who's another 60s moment here. So the layout manager is as we put components in, but what we're doing with this panel is we're not putting buttons and other things in. We're just going to be responding to the mouse. And what I'm hopefully leading up to is one in which we are just drawing some simple shapes and doing some simple customizations of them. Okay, so our mouse panel, we're going to extend J panel because if it is a J panel, we can treat it like a J panel. And again, I can make I'm making it private because this is an inner class. I set the layout to null because I actually don't want a layout. I'm not going to be putting widgets in here. I'm just going to be responding to the mouse. Now, by default, J panels are actually transparent and have no color. So in this case, I want to set the color. I'm going to set it to white because I can set it to any color that I want. Notice in the color class, the syntax of this, again, when all the things that we talked about earlier can be helpful to understand what the thing is that we're looking at. So this color.white is an instance of a color. And as you might guess, it's going to be the white color. But syntactically, this tells us that the color is a class. And because we are we have a variable, this tells us that white is a public static variable. And if we want to look at what that is, if we go to the declaration, we see that it is declared as a public static final. And that's, again, that's when one static variables, especially if they're static and final, is okay to be public because now I can't change that. And so if I want to see where this is defined, let's sort of find the usages of this here. Oops, that was right here. Somewhere this is defined. Somewhere else, I guess. Oh yeah, so for some reason it doesn't give us the code. So anyway, so we can understand what that is. So let's see here. Yeah, so I have one of these guys. So here's what it looks like. So again, our super, when we set the title to mouse listener, that set this title here. And when we set the background to white here, that made this white. If we set it to some other color, and the confirmation of the exit is done in the base class. If I set it to something other like red, then we have a delightful red background. So just in general, most of the widgets and most of the components have a background that we can set, and we can set it to, there are a variety of different ways of dealing with the color. Okay, so here what I want to do is I want to listen to the mouse. So what's happening with the mouse is, I want to listen to the mouse as it moves throughout the panel. So to that end, using the same pattern as we've had before, I'm going to create an inner class, and I'm going to implement a mouse motion listener is what it is. So okay, I'm already using mouse listener, so call it mouse tracker. Mouse motion listener. Okay, so the fact that I can say implements, okay, now it's complaining about it's not abstract and doesn't override abstract method, but because I can say implements and it doesn't give me red squigglies here, and why doesn't it? Because I've actually imported it. And we see that the mouse motion listener interface is in the package called java.awt.event. If you remember, AWT, what they called the abstract windowing toolkit, was the initial way that Java did these graphical interfaces. The original one turned out to be too clunky, so they came out with this swing that we've been talking about here. And swing, the AWT stuff is still in there. And there are things like these interfaces and whatever that are lightweight, and they decided not to change the whole thing, so that there can be a certain degree of backwards compatibility. So again, this is an interface because we can say implements and it won't complain. And just to be absolutely clear about this, when we go to the source, we see public interface mouse motion listener, and it extends another interface called the event listener. I want you to go to the source. For some reason, the Java seems to be messed up a little bit. Anyway, okay, so there's actually an interface hierarchy that we don't have to necessarily worry about. Okay, but we're still getting red squigglies. And the message says it's not abstract, does not override certain messages. So we implement all abstract methods, and we see that there are two methods in the mouse motion listener interface, one called mouse dragged and the other called mouse moved. And these do what they say, as I've sort of mentioned earlier in the course. What we want to do in programming, just in general, is make our variables and our methods as self-describing as possible. Now, there is this kind of Valhalla of self-documenting code, and it's a bit of a myth, but we can go partly there. Again, if this is the first time you've seen these methods, and by their name, they tell you at least what they should do. And so if the implementers, if we're not being unreasonable, then mouse moved is going to be what gets invoked when we move the mouse, and mouse dragged is going to be what's invoked if we drag the mouse. And you understand the difference between moving and dragging. In years past, we had to kind of explain that because people didn't necessarily use the mouse. I mean, in years past, a student would come in and never have used a computer with a mouse. So you had to kind of go through this. You've all been using mice in computers for many years, so this doesn't have to be explained to you. Okay, so here's what we're going to do is let's Okay, so when we move the mouse, we get this mouse event. And the mouse event has a number of different methods, one of which is to get the point. And we actually have two choices. One is get the location on the screen, which is where it is on your computer screen, or get the point, which is what we want, which is the XY position relative to the source component. We're going to be moving our mouse around that mouse panel that we had. And so what I want to report is what the location is on that on that point. Okay, so now how am I going to report that? I'm going to use the status label, so I can get the status label, and I'm going to set the text. And I'm going to use my string format. So if I'm moving, I'm going to say here I'm moving, and I'm going to tell you where I'm moving. Actually, I think I'm going to have to make these floats. 0. Okay. All right. So what do we have? I have my point has get X. Yeah, they're doubles. Oops. Get X. And Y. And there, as you might think, and now the thing to understand, well, we'll see this when we start doing this. And I'll do the same thing here. Only now what I'll do is I will say that I'll set the text to dragging. Okay, so, and I have to use the F rather than the D because the point 2D gives its X as doubles. So get X, get Y. Okay, so what we should be seeing is that if I move the mouse around in the panel, it will show me what the coordinates are relative to the panel. And if I'm dragging it, it will say that it's dragging it relative to the panel. Okay, so now how do I set that up? Well, I need to go back to my init event. And okay, I've already set up my mouse panel, but I want to have my mouse tracker instantiated. And then what I do is I add it as a mouse motion listener. Okay, again, the same pattern as we've seen before. We've seen with the window closing, if I want to listen to a window event, then as with the base frame and the window closer, then I implement, well, window listener, and then because I'm lazy, I extend window adapter and just override the one method that I want. If I'm listening to a button or something else, I'm an action listener. And so action performed is what gets called. And the way that gets set up is to add the window listener in this case, and in the case of action listener, it will be add action listener. Same pattern here. So this mouse motion listener is I instantiate it. And because it is a mouse motion listener, I can add it as a mouse motion listener to my mouse tracker. One thing that I hope is coming into focus a little bit is has to do with these interfaces. When we talked about interfaces and they were introduced, there was some question, and there should have been some question about, okay, why do these interfaces exist? Why do why do we need them? Hopefully you're beginning to see why. Like here we have a, just a couple methods, and I'm doing something very simple. When we start extending to this to something a little more useful, we're going to be using the same methods to basically, or similar methods to do something else. But in order to make it as lightweight as possible, I mean, all I need to know is that I'm a mouse motion listener. In other words, when I say add mouse motion listener, if we look at the signature of this, the method is a mouse motion listener. And so anything which implements the mouse motion listener interface, I can put in here. And I don't have to be tied down to any specific class hierarchy. I can just kind of, especially for lightweight things like this, I can just kind of do what I want. So hopefully that's becoming a little more clear as to the why of all that. Okay, so turn value is null. Okay, why is that null? Because I didn't do it. Okay, so my base class. Okay, you see what happened? What happened was I had defined the status label, but I had not instantiated it or added it. So now let's try this again here. Okay, so now I'm just moving the mouse around here, and you can see down here at the bottom, it says that I'm just moving it, and as I move it, the coordinates change. Now we can actually use this to kind of see what the coordinates are about. As I move it all the way up here, you see that the Y coordinates are decreasing. Okay, what are the units here? These are the pixels. The units are the pixels. And as you can see, what happens if I move it too quickly and I get pretty much near the top here. So you see that this Y coordinate shows us that the Y-axis in graphical interfaces, and this is true across the board, is upside down. If you remember from math class, the coordinates are typically X increases as it goes to the right, and Y increases as it goes up. For graphical interfaces, they turn that upside down. So the origin is actually up here. The origin is here. So 0x is here. And so as I move X to the right, the X coordinate increases. And likewise, if I move Y down, you'll see that the Y coordinate increases. Okay, and I'm just moving the mouse, but now what I'm doing is now I'm going to drag it. So I clicked it down, and as you can see now, it says that I'm dragging. It recognizes the fact that what dragging is I'm holding the mouse down and moving it around like that. Okay, so that is what that is about. So what have we seen? We've seen that our mouse events can be listened to. Now the mouse motion events can be listened to by something which implements the mouse motion listener. And we see that every time it's dragged or moved, so here's the moved, and we see that whenever it gets moved around, these mouse events get fired, and that's something that the virtual machine itself does. It may not be obvious, but many of these are kind of in the implementation of the virtual machine are kind of tied to what's going on, to very low level types of things. In other words, it needs to kind of know where the mouse is. And so there's code that's written in native language because it's going to be different for every operating system. But nevertheless, what this means is that at a high level, that means we don't have to worry about the mechanics down low. If we want to deal with the mouse itself, we can basically do that. So we can deal with the mouse listening, the mouse moving, and the mouse dragging. Okay, so we can deal with our mice that way. Right, I'm gonna commit this. And actually I'll push this. So if you want to do a pull right now, then we can deal with that. Okay, so all right, so now what do we do with the mouse? Well, so far in our early ones, we were using the mouse to click on buttons. We were using it to open menus. We were clicking inside of a text field and typing something there. So what I want to do now is add in something in that Java again produced a little bit later, and it's called the 2D framework. And what it is it's actually a set of classes which represent shapes, various kinds of shapes, lines, stuff like that. So we'll just look at some simple shapes. And what kind of the way it's set up is, if you can see this, kind of a piece of its class hierarchy looks something like this. Again, remember, everything is an object. There's an interface called shape and an abstract class called rectangular shape. And a rectangular shape is not necessarily what you might think. And this is an abstract class. There are two main subclasses that we're going to deal with. One is what I call a rectangle 2D, and the other is an ellipse 2D. So basically, these are the two main subclasses of this. And Java did something a little bit strange with this. Actually, the rectangle 2D class is an abstract class itself, and it has two concrete subclasses, which they've implemented as nested classes. And a nested class is like the inner class that we have, except that they're static rather than instance. So Java AWT geom rectangle 2D dot double implements extends the rectangle 2D, which in turn extends the rectangular shape, which in turn implements the shape interface, and represents its coordinates as doubles. There's another one which represents its coordinates as floats. So why did they do that? Well, in many graphics applications, they want to squeeze just a few extra little computer cycles, squeeze a little bit of extra room. And so a double uses twice the space of a float. And doing double arithmetic takes a little bit longer because we're dealing, a double uses 2 words to represent a floating point number, whereas a float only uses 1. My experience has been that float and using, the reason that we've always used doubles to represent numbers and not floats is that floats just have utterly unacceptable precision. And so I always use doubles. So now what these are not, these in and of themselves are not visual, but we can create visual things for them. So let's see what that is kind of about. Right, so now what I'm going to do is I'm going to make a copy of this. Well, no, I'm not going to. I'll just do it right here, and we'll kind of keep with that. All right, now here's the thing, is that I want to be able to draw stuff in this mouse panel. And so the way to do that is because I don't have a layout manager to do that thing. So I need to actually do it myself. So to that end, let's I'm going to create another instance variable. I'll call it drawn shape. We're going to start with 1, and tomorrow we'll expand it. Let's fix our imports here. Okay, so there's and we're going to leave that like that. So now how do we, what I want to do is I want to be able to draw that shape. And here's how I do it. I need to override a method called paint component. And what paint component has as its argument something called a graphics context. I'll call it G. And that's how things, super paint component. So whenever the component needs to be redrawn, at some point this paint component method is called. Come on. And we see we override it. Its argument is this thing called a graphics. And what they did, that kind of harkens back to the early days. And they the actual instance is something called the graphics 2D. So the pattern that's kind of emerged is we need to cast our graphics to a graphics 2D to do that. And so now, what we can do is, and that's because this has something called draw shape, or a draw shape. And let's draw shape to shape. What happened? Put the wrong one in here. What I want is the there it is. Okay, yes, it was getting confused by the shape that I'd done before. Okay, so, and actually I want to do that only if it's not null. Okay, so just to test this out, what I'm going to do is in the init, I'm going to create one of these things. And double. And what, okay, so I have two things. One is I can create one initialized to 0, 0 and size 0, 0. That's pretty lame. So instead, let's, again, what are these? We have X and Y, which are going to be location. So let's put it at maybe 100 pixels to the right, 100 pixels down. Let's make it, 200 pixels wide and 100 pixels deep. Okay, so now when I run this, I should see a rectangle. And we can see that the rectangle, see here, here's the point. And again, it's kind of hard to get exactly there. But what this tells me also is where it, what it means for a shape or anything here to be in a particular place. So notice I said, put it at X, Y, 100, 100. And I see that if I put my mouse exactly where that is, that it shows that it's 100, 100. In other words, the origin is at the upper left corner. So if I say to draw something at 100, 100, it'll start here and then draw it outward. Okay, so now the other thing is that, all right, it's nice and boring with the color. So I can change the color. So let's make it red. And what I do here is that again, I should, okay. I set the color, in this case to drawn color. So right before, so here's the way this graphics thing works, is that when it says draw, it's set up to draw whatever this thing is. And you notice that again, the argument, not for set color, the argument is a shape. And remember, because shape is the interface that all of these things implement, that means that anything that is a shape can be drawn here, and it'll draw it according to where it is on the screen and what its size is. So what I'm doing with this one is I want it to draw a red one. Okay, and we see that it's red. Now, what if I want, now the other one that I said was an ellipse. So let me overwrite, that's new, ellipse, 2D, again, double. And, let's put it at 200 and make it, 150 by 150. So now the thing, you say, well, what about a circle? What if I want a circle? Well, an ellipse is a circle if I make sure that the axes are exactly the same. Let's put them out there. Okay, so now I've kind of overridden this, and what I'm looking for is a red circle. Okay, and there's my red circle. Okay, so that's just to review what we've done. We've seen that the mouse, when we move it around, it has It lets us know where it is. If we drag it, we know that we can identify where it is, where we're dragging it to. Notice that when we move it, it's always, the mouse event is always identifying where it is. Likewise, when we drag it. And then the second thing that we've seen is that we have this interface shape that one of which, something called a rectangular shape actually implements that, and that's something that we're gonna use at some point. And that it has two subclasses, one that's a rectangle and one that's an ellipse. And then the rectangle in turn has two subclasses that are nested within it. Again, this is it's kind of a strange pattern. The Java 2D framework is the only place in Java where this is done. It kind of works for them. I'm not exactly fond of it. However, it is what they do. And so we're kind of stuck with it. The reason they did that is because they wanted this float thing as well, which to me, especially now that computers are really fast and really big in terms of memory and speed, the float thing, to me, the penalty you pay in lack of precision is really not worth it. Nevertheless, what we've seen is that we can set colors, we can draw things on the screen, we can, there are a number of, actually, as we'll see, there's, we even have cyan. What the heck is cyan? I've never heard of cyan before this, but we can draw it in a cyan. Okay, and you can see that's kind of a light bluish type of thing. And so where we want to take this is just a simple little drawing program. Say, well, okay, here's one shape, and we have to kind of manipulate the code here to do stuff. Can we do this and have a bunch of different shapes in different, both rectangles and ellipses, in different colors? And can we customize that? The answer, of course, is yes. And that will be what we talk about tomorrow.